Okay, in example 1, we look at a curve that is defined by the following parametric equation. So a curve C is defined by x equals t squared and y equals t cubed minus 3t. With part A, we need to show that C has two tangents at x equals 3, y equals 0. Part B, we need to find points where the tangent, where C has horizontal tangents and C has vertical tangent. I put it in a plural form, but in the reality is that we have two horizontal and one vertical. Part C is sketch the curve. There is another part that has to do with concavity. Concavity has to do with the second derivative. I'll keep that discussion for a later time. So, how we proceed from that? One thing that students that learn calculus with parametric equation need reminding is you're dealing with three variables really. You have the x variable, you have the y variable, but remember x by itself is a function of the parameter, which is the third variable t, and y itself is a function of this parameter, the third variable t. So keep that in mind, and we'll go from here. We'll keep this in mind as we go on to solve this particular problem. So we're looking at problem at the first part, where we need to show that at x equal 3, y equals 0, we have two tangents. Okay? The idea is to find the corresponding values of t. For instance, when x equals 3, since x equal t squared, then t squared equals 3, and therefore t equal plus or minus square root of 3. Okay? That by itself is sufficient to show you that there are going to be two tangents. One corresponds to t equals square root of 3, and the other corresponds to t equals negative square root of 3. What happened when y equals 0? Well, y is t cubed minus 3t, then it's equal to 0, and get here t times t squared minus 3 equals 0. So here we have, again, the t squared equals 3, but also now we have t equals 0 as well. So t equals 0 is one solution, and here we have t equals plus minus square root of 3. So dealing with y equals 0 has to have, we have t equals 0 as well. But here's the thing. We need to satisfy x equals 3 and y equals 0 at the same time. Okay? Since t equals 0 does not give us x equals 3, then we're going to reject that solution. So here's a note. We need to satisfy both x equals 3 and y equals 0 simultaneously. Okay? The only t solution that satisfies both is t equal plus minus square root of 3. So we're going to reject the t equals 0. Later on we're going to see the meaning of t equals 0. So what happened when t equals square root of 3, plus or minus square root of 3? We still need to come up with the tangent equation itself. So we're going to now go and talk about dy dx. Well, dy dx equals dy dt over dx dt, and we need to figure this out when t equals square root of 3. So let's look at what is dy dt. Well, dy dt is since y equals t cubed minus 3t is 3t squared minus 3, and dy dt when t equals positive square root of 3 equal to 3 times square root of 3 squared minus 3. Well, this will be 6. Okay? What happens if we have negative? Well, it's the same result, so we don't care about it's plus minus. As you can see here, let me write it in a clearer way. Because we square the square root of 3, so okay, in invisible ink right now you see plus minus square root of 3 until the whiteout will dry. Okay, what about the x dt? Well, the x dt, since x equals t squared, is simply 2t, and the x dt, here we have a difference. When t equals square root of 3, well, it's equals 2 square root of 3, and dx dt, when t equals negative square root of 3, equals negative 2 square root of 3. So we have two values for the derivative. So going back here, time to put the plus minus square root of 3. Okay, so it becomes visible. So dy dx equal either six over 2 square root of 3, and this will be 3 over square root of 3, or simply square root of 3, and dy dx also equals negative square root of 3 if we choose, if we go with t equals negative square root of 3. So what are the equation of the tangent? Y equal, for positive square root of 3, it will be square root of 3 times x minus 3 plus 0, and for negative, it will be y equals negative square root of 3 times x minus 3, like so. Okay? And this is the solution to part A. Part B, in part B we need to talk about horizontal and vertical tangent. Go back and look at this result right here that we had in the earlier. Well, for horizontal tangent, we need dy dx to equal 0, right? And to do so, if you look right here, for dy dx to equal 0, then we require dy over dt to equal 0. For vertical tangent, we want dy dx to equal infinity. In other words, we want to divide by 0, and therefore we're going to require dx dt to equal 0. And again, this is something that you're not familiar with, although we looked at it earlier in the semester. There was a question about the vertical asymptote. We looked at it also when we did, those of you who had me for Calc 1, we did implicit, if you remember implicit curves, we looked at, there was a lab where we looked at vertical tangent, and we said, okay, the vertical tangent is either when dy dx equal infinity or dx dy equals 0. Okay, so that's another way to look at it. Horizontal tangent dy dx equals 0, and vertical tangent dx dy equals 0. If dx dy equals 0, then dx dt has to equal 0. Anyway, this is the important part. So now we are after those values. What we're going to do next is we're going to find t for which dy dt equals 0. We want to find t for which dx dt equals 0. And then we're going to find the points based on that. Okay? Again, remember the three variable game here. You have x, y, but you have t. And really t is the variable for both x and y. So the name of the game is find t. So let's find this t. And we start with dy dt equals 0. And this required dy dt, we already calculated it. It's 3t squared minus 3, isn't it? So we want 3t squared minus 3 to equal 0. And this happened when what? T squared equals 1 or t equals plus minus 1. Okay? So those values of t will give us points where the tangent is horizontal. So what happened when t equals 1? When t equals 1, what happened to x? Well, x was t squared. So x equals 1 and y equals t cubed. So y equals 1 cubed minus 3 times 1. And this gives us negative 2. Okay? When t equals negative 1, then x equals negative 1 squared, still equal 1, and y equals negative 1 cubed minus 3 times negative 1. So this is a little bit different story. It's negative 1 plus 3, so it's positive 2. So we now can we can write the answer. So we have horizontal tangent we have 1 and negative 2, and we have negative and 1 and positive 2. So obviously this curve is not a function, as you can see, because here we have a violation of the vertical line rule. Okay, so this is the answer to horizontal tangent. What about vertical tangent? Well, for vertical tangent, we require dx dt to equal 0. So this means that since x equals t squared, dx dt equals 2t, or get 2t equals 0, or t equals 0. Okay, so only one value like that. So what happened when t equals 0? What happened to x? Well, x equals 0 squared, and y equals t cubed minus 3t. So y equals 0 as well. So turn out that we have vertical tangent at 0, 0 at the origin. Okay? And now if we sketch this graph or graph it, you can see that this result really holds. If you sketch it, you'll see something like this. We know that we go through 0, 0, and 3, 0. That's given to us. We know that we have horizontal tangent at 1 and 2 and 1 and negative 2, like so. Okay, so we have horizontal tangent right here and right here. We have vertical tangent at 0, 0, like so. And we pass this through that. Since I have a way to see the future, I can tell you that the graph does the following loop. It starts right here at 0, 0, at t equals 0, we are right here at 0, 0. We already established that from here. And then it will go down to 1 and negative 2, and it will go up like so. And if we go back in time, at t negative, it will go up here and will go down like so. And to see it, okay. All right, so when t equals 0, we are right here. But if we'll move a little bit, let's go t equals 0.2. Okay? You can see that we're going down. When t equals 0.5, you can see where we are. T equal 0.9. You see the progression. When t equals 1, and then when t equals square root of 3 is 1.7. So that's where we are supposed to have the horizontal tangent. When t equals 5, we are off the grid. I went too far. So let's go 3. I'm off the grid. Let's go 2. I'm here. So we started right here, and we went down this way, and then up. For negative values of t, we're going to start at 0. Well, if you go back in time, we go down this way. So the curve comes from, let's say, from sometimes in the past, we go up, 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 at t equals 0 right here, then we go like so. And this is something that with animation, you can see it very well. Okay, I'm going to stop here. I'm going to give you back your tests.